Congruence. We've done the 2D shapes part of congruence, which is just finding shapes that match, that are exactly the same. We're going to look at proof, specifically with triangles. Triangles comes up a lot more on the higher papers. In fact, it's pretty much the only thing that comes up with congruence because there's special cases of triangles. So a question might be, prove that the triangles on your screen are congruent to each other. So you can't just simply say they're the same or they are congruent. You have to use specific language, which you're going to look at now. Just a heads up, what I've written in the brackets here, SSS, AAS, and so on, that's related to what you guys are going to be doing in this video. So the idea of congruence, do not copy any of these slides until I get to the slide that says copy the notes, because this is just an ideas, kind of looking at ideas in depth. So suppose these two triangles have side lengths given and they match. All three side lengths match for both triangles. Do they have to be congruent? So take a second to think about that. So yep, so you hopefully figured out where if they're all exactly the same size, then yes, they are going to be congruent to each other because the sides will determine the angles. If I made the green side on this triangle on the right bigger, well, then all of the angles change and the shape's not the same as the one on the left. Would the same be true if two quadrilaterals had the same lengths? Not necessarily. So a square and a rhombus have the same side lengths, but they are different shapes. So triangles are a special case where we're going to look at in a bit more detail. Quadrilaterals, we don't have to worry about those for now. In fact, I don't think we will cover similar shapes with quadrilaterals. It's not really a topic that we do. So what I want to look at this idea in a bit more depth is, we've already discussed, you can see on the top right-hand corner, if three sides are the same for two triangles, then they are congruent. That's enough to show that they're the same. Now, question A. Now, normally in a class, I'd get you to kind of discuss this a bit more in pairs and maybe do a bit more interactive, but we just have to do this over a video now. So I'll kind of talk you through it. So let's say we have two triangles. We're looking at question A. The two side lengths are the same and the angle between them is also the same. So you can see they're labeled as such. Does it mean that they are congruent to each other? Well, if you think about the third length, which we don't know, that's not really possible to change that length. If those two other lengths are fixed and the angle is fixed, well, the third length has to be the same, which means that they have to be congruent to each other. So we've just discovered or kind of just found out that the length, the side, the angle, and the side, if they match, then the triangles are congruent. Again, don't copy any notes on this yet. For question B, what happens if all of the angles in two triangles match up? So let's just say that's 38, that's 42, and then that's another angle that adds up to 180. And the same is here. Are those two triangles congruent? If you think about it, no, it doesn't work, because the triangle on the right might be twice as big, even though the angles match. So it's not enough to prove that they are congruent. It's possible that they are, but it's not enough as a proof. For question C, two triangles are the same. Sorry, two angles are the same, and the side, one of the sides is the same. Well, let's think about what would happen here. If we know that those two angles match, well, that means the third angle has to be the same too, because we can just do 180 minus those two angles. And if that length has to match, well, then it's not possible to have the same angles unless they are congruent. So we can say that angle, angle, side, or side, angle, angle is enough to prove that they're congruent. And then for question D, two sides are the same and the angle that's not between them. In this case, have a think to see what, could you change anything here to show that they are congruent or not? So the answer to that is, if that angle is fixed and those two lengths are fixed, it's not necessarily enough to prove that they're congruent. And I'm going to show you why on the next video. So what I want you to do before you watch the next video is this question here. It should take you about 20 seconds to do. Draw a triangle with the following properties. One length is 7. The opposite is opposite a 42-degree angle. Another length is 8 centimeters, and the third length is unknown. So you're just sketching it out. You don't have to draw it accurately. Just a quick triangle. Label the lengths. See if you can come up with 2 possible answers for this, and I'll see you in the next video.